Hello everyone, this is a question of CSIR-NET and in this question, let P be a prime number and corresponding to this prime number, we have NP be the number of pairs of positive integers x, y that satisfy 1 upon x plus 1 upon y equals to 1 upon p power 4. And in this question, which among the following are possible values of NP? In this question, I explained that NP for each prime number, NP either 9 or multiple of 9, where M belongs to set of natural number. Now for this question, let S be a set of x, y belongs to n cross n such that 1 upon x plus 1 upon y equals to 1 upon p power 4, where p is a fixed prime number. And corresponding to this p, we have np, which is equals to cardinality of set S. Now firstly, I prove that np for each prime number, np not equals to 0. Let x is equals to y. This implies that 1 upon x plus 1 upon x is equals to 1 upon p power 4. This implies that 2 upon x equals to 1 upon p power 4. This implies that x upon 2 is equals to p power 4, and further implies that x is equals to 2p power 4. So we conclude that for x is equals to y equals to 2p4, which belongs to set of natural number, and p not equals to 0. This implies that option A is incorrect. From the above explanation, we have np not equals to 0 for every prime number. Now this implies that for each prime number p, there exists x, y belongs to n cross n such that 1 upon x plus 1 upon y equals to 1 upon p power 4. Now for this question, I take p is equals to 2, and you can also choose any prime number for this question. When p is equals to 2 implies there exists x, y belongs to n cross n. This also means that x, y belongs to n, such that 1 upon x plus 1 upon y equals to 2 power 4, which is equals to 1 upon 16. Again simplify this, we have 1 upon y equals to 1 upon 16 minus 1 upon x, and this further implies that x minus 16 upon 16x. So y equals to 16x upon x minus 16. Note this expression. As p is equals to 2, xy belongs to n cross n. For simplicity, y is equals to n belongs to set of natural number, and this is fixed number. Now this implies that there must exist x belongs to set of natural number such that 16x upon x minus 16 is equals to n. When we solve this expression, this convert to x is equals to 16n upon n minus 16, which belongs to set of natural number. X is equals to 16n upon n minus 16, which belongs to set of natural number. Now x is equals to 16n upon n minus 16 belongs to set of natural number if and only if either 16n is equals to n minus 16 or n minus 16 divide 16n. This implies that n equals to minus 16 upon 15, but this not belongs to set of natural number, so we left only this equation, and this implies that n minus 16 divides 16n. So if n minus 16 divide 16n, this implies that 16n equals to 16 n minus 16 plus 256. This implies that 256 must be congruent to 0 mod n minus 16, because n minus 16 fully divides 16n. So remainder must be congruent to 0 mod n minus 16, and this further implies that 2 power 8 congruent to 0 mod n minus 16, and this implies that n minus 16 divide 2 power 8. As we know that, and this implies that n minus 16 equals to 1 or 2 power 1 or 2 power 2 or 2 power 3 or 2 power 8, and this implies that possibility of n are 16 plus 1, 16 plus 2, 16 plus 2 power 2, and so on, 16 plus 2 power 8, implies that number of possibility of n, that is y, are 9. So corresponding to each y, we also have x, and this implies that corresponding to y, we have x. This implies that we have either 9 or multiple of 9 possibility where m belongs to set of natural number. So come to options. Option B incorrect, option C incorrect, and option D correct. This is a 4.75 marks question.